Hello student, how are you? I hope you all are fine. In this video we are going to learn real number and their decimal expansions. Let's see decimal expansion of a real number. Suppose that we have to find out the decimal expansion of 10 upon 3. So when we find the decimal expansion of 10 upon 3, so we get 3.333 and so on like that. Like that 1 upon 2 is equal to 0.5. So we conclude that the decimal expansion of real rational numbers or a real number is end after a steps are non-end. It is non-terminating. It is not ending after a steps. So decimal expansions terminates or end after a finite number of steps. So we call the decimal expansions of such number terminating. See there, 1 upon 2 is equal to 0.5. Decimal expansion of 1 upon 2 is 0.5. It is end after a steps. So that is 0.5 is terminating. But in 10 upon 3 we seen that decimal expansion is not terminating. It is repeating only. Like 1 upon 2 0.5, 639 upon 250 is equal to decimal expansion of 639 upon 250 is 2.556. It is also terminates. Decimal expansion of 250 upon 200 is 1.25. It is also terminating. But in second we are seeing 1 upon 3, that is 0.333. 14 upon 11 is equal to 1.2727. So 27 is repeating there. So we can also write here 1.27. That two digits are repeating continuously. So we have repeating block of a digit in quotient. Here we have repeating block of one digit, and here we have two repeating block of two digits in that quotient. These decimal expansion are non-terminating, recurring. So students, we conclude that decimal expansion of irrational numbers is non-terminating, non-recurring, and decimal expansion of rational number is terminating and recurring. Non-terminating then recurring. But irrational number is non-terminating, non-recurring. Like that 1.414235 and so on. 0.10010001000 and so on. This is decimal expansion of irrational number, but that one is the decimal expansion of rational number. Now we have a question: find irrational number between 1 upon 7 and 2 upon 7. Like in last video we learned find the rational number between two given rational number, and today we will learn find the irrational number between two irrational number, 1 upon 7 and 2 upon 7. So we may write 1 upon 7 is equal to 0.14285. That is, this 6 block of digit is repeating. So we may write 2 upon 7 is equal to 2 into 1 upon 7, as you know that. 2 into 1 upon 7. So 1 upon 7 is 0.142857. Now we will multiply 142,857 by 2. So we get 0.25714. That is repeating. So we have to find a number which is not terminating, line between these numbers 1 upon 7 and 2 upon 7. So such numbers may be 0.150. 1500, 1500, there should be 0, 15000 and so on. So 0.15 is greater than 0.14285, but it is less than 0.285714 and so on. Like that, these numbers 160, 1600, 16000 and 0.210, 2100, 2100. These all numbers will be lying between 1 upon 7 and 2 upon 7. Now question number second. So that 1.353535 is 1.35 is repeating. There are two digits which is repeating. Can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. As we know that 1.3535, that is a decimal expansion of a number which is non-terminating repeating. It means this decimal expansion is a expansion of a rational number. So we have to represent 1.3535 in the form of p by q, which is a rational number. Let's see the solution. Let what you are given 1.35. So first we will consider 1.35 is equal to x. That is x is equal to 1.35. That is repeating. We consider this is the equation number 1. So since two digits are repeating, we are seeing in this expression two digits are repeating. So we have to multiply x by 100 to get 100x is equal to, when you multiply it by 10, 100 and here also 100. So what we get? 100x is equal to 135.3535 and so on. Okay, so now we have two equations, equation 1 and equation 2. Equation 1 and equation 2. So 100x is equal to 135.3535 and so on, and x is equal to 1.353535 and so on. So now we will subtracting equation 1 from equation 2. We get, when you subtract equation 1 from equation 2, so what we get? 100x minus x. We have to subtract the left hand side from left hand side. So 100x minus x, 100x minus x is equal to 135.3535 minus 1.3535 and so on. Now 100x minus x is equal to 99x, and we will subtract it, so we get 135 minus 1, that is 134.0. So we can write 99x is equal to 135. We have to find the value of x, because we already considered 1.35 as a x. So x is equal to 134 upon 99. I hope it is clear. Okay, thank you. Okay student, this is second question. Express 0.47 in the form of p by q. Here in this expression only 7 is repeating. Only 7 is repeating, not 4 is not repeating, only 7 is repeating. Pay attention there. So let's consider x is equal to 0.47. Equation number 1. Since one digit is repeating, then we will multiply this equation by 10. So we get 10x is equal to 0.47, where 7 is repeating, multiplied by 10. So we get 10x is equal to 4.77. Equation number 2. Now we will subtract equation 1 from equation 2. So we get, subtract equation 1 from equation 2, and we get, what we get? We will subtract it, so we will subtract the left hand side from left hand side. So 10x minus x, 10x minus x is equal to 4.7, where 7 is repeating, minus 0.47, where 7 is repeating, and so on. So 9x is equal to, subtract it, what you will get? 4.3. When you will subtract it, what you will get? 4.3. Now 9x is equal to 4.3. X is equal to 4.3. So we have to find the value of x. X is equal to 43 upon 90. X is equal to 4.3 upon 9. So x is equal to 43 upon 90. That's